Welcome to Altair Engineering Training and Support. Uh, in this video, I am going to show you how to do roll cage 1D geometry editing and meshing. So we'll start with, in this video, I am going to cover how to move or assign the surfaces or lines in one component, as sometimes during the import from any of the CAD software, the lines and surfaces comes in 15 or 20 different components. So how to move or assign them in one single component, so it will be easy to handle that particular geometry. Then how to connect all the lines of the roll cage, because in the CAD software sometimes you just create the lines but they are not properly connected with each other. So the line segment, that is the beam segments, the pipe segments has to be connected. So we'll check one by one the pipe segments that has to be properly connected, because in some of the softwares they don't find the connectivity as the main issue, but actual practice or in actual practical problems, that is the biggest issue, that is it has to be properly connected. So if any of the software is not showing you the connectivity issues, or it is not allowing you to connect the lines and the geometry properly, so that means there is some errors will happen. The results will not be the accuracy of the results will not be very high. So we'll see how to connect these lines. That is very important, to connect all the lines properly. Then we'll see how to create materials. So in this tutorial I'm going to show you how to create two different materials. If you want to create, if you have two different material cross-sectional pipes, so how to create those materials. Then how to define the cross sections, as in this tutorial I'm going to show you how to create a hollow circular cross section as well as a square hollow square cross section. If you have a hollow cross section, then how to create that and define that also I will show. Otherwise, if you don't have any hollow square cross section, then you can directly go with the hollow circular cross section. Then next is I will show you how to create 1D property. That is, after defining the cross section, we will create a property in which we define the areas, so that my software will create the required matrix to find the stresses and displacement. Then we will see how to create proper components with the proper properties. So all my elements will get the proper material and cross sections. Then how to do 1D meshing using line mesh panel and bar panel. So we'll use two different panels available in HyperMesh version 12, that is line mesh and bars. In line mesh we will do the auto meshing, and then we will check where are the meshing, the 1D meshing is not proper, so we'll edit those 1D meshing using the bar panels. Then we will view and correct the free 1D elements. If there is any free 1D element, we will view those and correct them properly. Then we will assign the proper orientation to the element, because in sometimes it shows some errors like the orientation is not proper. So I will show you how to orient, have the proper orientation. Then how to do a free run to check the elements connectivity and quality. So lastly we will do a free run where we input a frequency range from 1 to 1000, say, let's suppose, and excite that model to my aim is to check the connectivity, that all the beams has to be properly connected. If there is somewhere is there a connectivity gap, then it will come out. Otherwise my beam has to be properly connected. And the another aim of this free run is to check the elements quality, because some of the softwares, they don't go for the quality checks. Whatsoever the mesh is, whatsoever the geometry is, they just perform the run. That is not proper, because there are some qualities which has to be clarified, particularly like the connectivity issues and the aspect ratios and different quality checks, because analysis will be done in the matrix format, and they have some interpolation functions. So if the shape of the element is not proper as per the interpolation function, the results, the interpolated results will not be accurate. So there will be a big difference in it. So that is why it is very important to have the element quality check and connectivity checks. And then lastly we will see the results in HyperView, that I'll show you how to view the results in HyperView, and somewhere how to capture the images, make it very attractive to put it in your presentation. So I'll show you that also. So we'll start our session with opening of the HyperMesh. So to open the HyperMesh, you can go to Start. In Start, go to All Programs. All Programs, click on HyperWorks 12, click on HyperMesh. Once you click on HyperMesh, it will open the HyperMesh license window first. That it will show you how many days of your license is left to expire. So this type of message appears that one or more of the required features checked out will expire in 11 days. So this is the license message, that the license will get expired in 11 days. So click OK. It is not an error. Just click OK. It will open the HyperMesh GUI. Once the GUI open, it will load the user profile window. That is most important window, that you can create in HyperMesh different decks for different solvers. HyperMesh is a preprocessor, so we just create a meshing, apply the loads and boundary condition, and can solve in any of the solvers available, like Radios, OptiStruct, Abacus, ANSYS, LS-DYNA, Nastran, PAMCrash, any of these solvers you can solve that particular model. So different solver require different deck. So according to their solvers, you have to create their particular deck in HyperMesh. So you can create any deck in HyperMesh. Then select, as we are going to solve this model using Radios as the solver, so we'll select Radios bulk data, because we are performing linear static analysis. That is, if you want to perform the dynamic or implicit analysis, select block datas. They are a different format for the Radios. Otherwise, if you are performing normal modal linear static analysis, then you select Radios bulk data. Okay. Then click on OK. If the user profile window doesn't appear on your after opening the HyperMesh GUI, go to Preferences. Don't worry about it. Go to Preferences, User Profile. The user profile window will appear. Just select Radios, user profile, bulk data, click OK. It will load the user profile. On the top of your screen, you can see a user profile has been created. So now I will show you how to import a CAD model or a line data structure on any CAD file into HyperMesh GUI. So there are two options to import a CAD model. First is, you can click on this icon to import the CAD model. That is, go to drop down, import geometry. This will show you the import panel, or go to files, import geometry. So there are two options through which you can import the CAD model into HyperMesh. Select the file type as auto detect, because it can automatically detect whether it is a CATIA file, IGS file, Parasolid, JT, ProE, whatever the file format is, it will automatically detect it. Then click on Open Folder, that is the Browse Location folder. Click here and select the file which you want to import. Keep all the parameters as it is. I will show you what exactly we need to do with these parameters. And then click on Import. Once you click on Import, click on Close to close the model browser. So once your model get imported, the first thing we have to do is to check whether my model is in mm, meter, inches, in which scale it is. So in which unit it is actually. So we have to check that first, because to find the value of stresses, generally it is easy to find out the value of ultimate stress or yield stress to be Newton per mm square. Also, to input the material properties like E, nu and rho value stuff, it is always easy to input the values in mm. So or the momentum in Newton per mm, that is different stuff in mm. It's very easy to find out. So always make sure your model is in mm. So to check whether my model, the model which I imported is in mm or not, I need to create two nodes on any of the line which I know the distance. So this baseline, I know the distance that it has to be somewhere around 380 plus mm, somewhere around. So to find out this length distance, I'll go to geometry page. In geometry page, click on length. Select the line and click on length. So as you can see, its length is coming as 0.38 e to the power minus 1, means somewhere it's 0.3. If it's a 0.3, that means it is this model comes in meters. It is not in mm, it is in meters. So when I created in CAD, I use the format as meters. So this model is imported in meters. So I have to import it again in mm. So I will show you how to import this model again in mm. So again, go to import icon, select the same file, just change the scale factor as 1000 and click on import. So once you click on import, you can see your model get imported. So this is your base model. I will create some nodes here, so it will be easy to rectify it. So this node is on the roll cage, having the unit as meters, and this is the roll cage with the length. Again, go to geometry, length, select this line and click on length. So you can see here now the length is 381 mm. So that means now it is in mm. So the format has to be proper. HyperMesh doesn't take any particular unit, it takes the number. So the number which you enter, the results in the same way you will get the results. So if you enter the numbers as per mm, so you will get the results in mm. If you enter the numbers in inches, you will get the results in inches or Newton or ton. So accordingly it will provide you the results and values. Okay. So in this way I have imported a model in mm. If you have a inch model, then I'll again show you. I'll again say new. I will show you for the inch model that this is the inches. I will say 1, import. So if I go to geometry, length, click on length. So it's a 15 inch. The length of this is 15 inch. So I will change the scale factor as 25.4 and say import. So now you can see this is the model in inches and this one is the model in meters, sorry, mm. Okay. So whatsoever the unit you have followed, make sure your model should be in mm. So you have to just change the scale factor here. First check whether it is in inches, meters, what is the in centimeters. If it is in centimeters, just multiply it by 10, so it will come as mm. So what is the unit factor you are using? What is the SI unit? What are the units you are using? So accordingly convert that into, on the import panel, convert it into mm. So I will again say new, import this model directly into mm. So I will check again, geometry, length, click on this length. So it is coming as 380. That is perfect. So now my model is in mm. Now the next step is once I click close to the import option, I will enter to the model panel and I can see here there are 11 components in my model. So there are different components. So it doesn't matter if we have 10, 15, 100 components, but to handle that, so in each component there are different lines. You can see if I off this, so these one line, this is the second. So there are different line segments in the different components. This is also due to the import from CAD software. Sometimes it comes in a single component, sometimes it comes with a multiple components. So we can easily move all these lines to one component that I will show you how to move all these lines in single component. That this one is not a 2D structure, 2D or solid structure. This is the line data. That is the center line of the actual roll cage structure, which I have created in a CAD software. Any of the CAD software you can create. So many times people get confused. That is, they find out that it is coming as two lines. So if it's coming as 2 lines, that means it is a solid structure. It has to be a single line for each beams, as you can see here. Okay, so I will create one more component as roll cage line data and move all these lines from these different components to that particular component. So I will go to component. I will enter the name of the component as roll cage line data. Change this color to say red and say create. So you can see my roll cage line data component has got created. Now I will go to geometry, or I can go to organize or to move these lines into single component. Go to tools, in tools, click on organize, or press shift plus F11 from your keyboard. That is a short key of it. So you can either press shift plus F11 from your keyboard to enter to organize panel, or go to tools, organize, that is the same panel. Okay, so select all the lines. You can press shift left mouse button and drag the window. So it will select all the lines. Select the destination component, that is in which component you want to move these lines. So I will select the roll cage line data and click on move. Once you click on move, if I off the geometry, this comes for geometry, this comes for meshing, to on and off the geometry and meshing. So if I off the geometry of this or the line data of this roll cage line data, so you can see there is no lines available now in these 11 components. So now I can just select all these from, I will press shift, select the first, press shift to select the last, and I will just delete all these. So now I have one single component with me, which contains the line data. So before starting to meshing and material creation, property defining, cross sections, everything, we will first check whether this roll cage structure is properly connected or not. It has to be properly connected with each segment. Properly connected, that means, what I want to say is, if I go to any of the panels, so if I go to delete panel, select this line, so you can see this line comes as a straight single line, but practically this line has to be from this point to this point, and from this point to this point. From this point to this point, one single line, and from this point to this point, one single line. But right now it is coming as one straight line without an intersection. So I have to see whether all my geometries are properly connected or not, or if not, then I'll have to connect them. So how you can connect or edit these lines? So there are two ways. Either you can do the meshing and then do the geometry connection, or you just go through the geometry connection first and then do the meshing. The second option, that is to do the geometry editing first and then go for the meshing, is the best one, because if you want to change the element size, the mesh qualities and different things, if the geometry is perfect, you need not to have changed the meshing every time. So it will be more easy for you. So I suggest you to go for the geometry editing first and then go for the meshing. So as I need to connect this end to this end, I require node at this end, so that from this node to this node I can create two different lines. So I will go to F8, press F8 from your keyboard. That is the shortcut for nodes panel. Simple F8 from your keyboard, or go to geometry nodes. Both are the same panel. Go to the fourth option, 1, 2, 3, 4. From drop box, select extract on line, or select extract parametric. Select this line, click enter the number as 2, keep all the other parameters as it is and click create. Similarly, select this line and say create. So it will create all the nodes. So I require only this to this node, this to this node to create the line. So now I will delete first this line, the actual one, and I will now create a new line by the reference of these nodes which I have created. So go to geometry, lines, on geometry page, click on lines. Select second option, that is linear nodes. From this node to this node, create a line. From this node to this node, create one more line. So now again, if I go to delete panel, you can see there are 2 different lines. Similarly at this end, this end also the issue is same, that is the lines are not properly connected. So rest of the things are okay. So same process you will follow. Press F8, create the nodes, delete this line, go to lines panel, that is geometry lines. From this node to this line, create a line. From this to this, create a line. Then press again, go to geometry page, temporary nodes. Once the work of these nodes completed, click on clear all. Go to node, geometry, temporary nodes and say clear all. So it will clear all the nodes. Now we will check one by one again from this end. So this is okay, this one is okay, this is okay. So all these lines are properly connected. So again you can see on the top the lines are not properly connected, as you can see. Rest they are, as you can see here. So for this section only these 2 lines are not properly connected, otherwise all are properly connected. So again I will follow the same. F8, create nodes here, create nodes here. Go to F2 to delete panel, delete these lines. Nodes, lines, second option, that is from Dropbox linear nodes. From this node to this node, create one line. From this node to this node, create one line. From this node to this node, go to create. From this node to this node, if you press, after selecting the nodes, if you press the scroll button, the highlighted option will be handled. If as the result is highlighted, return is highlighted, click here, so it will click on the return. Again press shift F2 from your keyboard to enter to temporary nodes panel and clear the nodes. Now again press F2 and check. So here and here these 2 are not properly connected. So again press F8 from your keyboard, create the nodes. F2, delete these lines. Geometry lines, from this end to this end, from this end to this end. Shift F2, clear all. Again F2, this is not connected, as you can see. We will check for this. So these are connected. So these all are properly connected now, as you can see. So again, as this you can see they are not connected. So press F8, create 2 nodes, create 2 nodes here. Go to F2, delete this, press escape. From this node to this node, create one line. From this node to this node, create another line. Similarly from this end to this end, create and create one more line from this node to this node. Similarly, as the top one ends, so I will select the bottom one. So this is done, this is done, this is properly connected, this is also properly connected. This is the straight line, there is no connection. Now for this, as you can see, that is not properly connected. So I will again go to F8, create two nodes, F2, delete, from this node to this node create, from this node to this node create, shift F2 and clear all. Again go to F2, there is no connection on this, so it is properly connected. This is properly connected. This one is also properly connected. This one is also. But not the this one. So as you can see, this is a straight single line. So I will again press F8 from my keyboard, create this, then delete these lines. From this node to this node create, this node to this node create, this node to this node create, this node to. So I will manually first check and clear the connectivity issues. Rest of the things we will do after the free run if we missed any. Then press F2 and these are all also not connected, as you can see. So we need to connect them also. Here also this is the cross section and it is not connected. So I will rectify it later on. First I will solve these four. So F8 again, this two nodes, this two nodes. So I will delete these lines. From this end to this end create, this end to this end create. Shift F2, clear all. So this has been created. Now this one, as it is not properly connected, so F8 again, interpolation, this line and this line create. So it will create in the same option, that is F8, that is node, select the last for the intersection points and it will find the intersection point. Then again press F8, go to this option and create the nodes at the extreme so that we can create the lines. Delete these lines. From this node to this create, this node to this create, this end to this create, this end to this create. So now this one is created. Shift F2, clear the nodes. Now we'll see about the bottom one. So it is, as you can see, this one is also. So again press F8 from the keyboard, this end, this end, this. F2, delete these lines. From this end to this end create, this to this create. Similarly from here to here create. Shift F2 again and clear all. So up till this everything is done. Now the last, these all are not connected, as you can see. So again press F8, go to intersection, this line and this line intersection, this line and this line create intersection point, this line and this line create intersection point. So we need these intersection points, and then again go to fourth option, these two nodes, these two nodes, these two nodes. So once I delete these lines, I have the nodes to create it. So go to geometry, lines, second option, that is linear nodes. This node to this node create, this node to this node create, this node to this node create, from this end to this end create, this end to this end create, then this end to this end create. So now you can see my geometry is properly connected. All the cross sections are properly joined. So you have to first check manually that all these are properly joined. Generally it happens when there is a straight beams like this, where you just create a line data, or in CAD software itself you can just create from this end to this end, create one line, and then from this to this create another line. So in either in CAD you have to do it, otherwise you can do in HyperMesh also. So in this way my geometry editing is done. If required we will do later on as per the requirement. Up till now my geometry editing is done. So I will directly move to create the material first, because we follow a process that first we create the material, then the cross section, then property, and then component. We'll go step by step, and after creating component we will do the meshing. So first of all we'll create the material as say steel. Select the type as isotropic, card image as mat 1. So mat 1 and mat 4 there is a difference. I'll show you again. Go to click on this icon to create material. Enter the material name as steel, type as isotropic, card image as mat 1. There is a small difference between mat 1 and mat 4 card image. That is, if you want to import, input the values of thermal coefficient, then just provide card image as mat 4. Otherwise, if you don't want to perform a thermal analysis, or you don't want to input the values of thermal coefficient, select mat 1 card image and click on create edit. Then input the values of E, nu and rho. That is the required, basic required. Don't input the values of G if you are inputting the value of E, nu and rho. Either you put the value of E or G. Don't put both E and G. I suggested that always put the values of E, nu and rho. If you have different materials, so always enter this value as per the dimensions available here, that is Newton per mm square, or in mm or Newton, enter these values. So click return. Now on the model browser you can see my material has got created as steel. Now the next step is to define the cross section. So to define the cross section, click on geometry, or to define the cross section you have to click on 1D page. On 1D page click on hyperbeam. So in 1D page click on hyperbeam, select the third option as standard section. In standard section library select hyperbeam, and standard section type select thin wall tube. So here we will define two different cross section. One is thin wall tube and for the circular cross section, and another one is hollow thin walled box for the hollow square section. So first I will select from the drop box hyperbeam, and from the drop box thin wall tube for circular cross section, and click on create. Once you click create, it will move you towards the hyperbeam GUI. Enter the inner radius and outer radius of the cross section. Please make sure to enter the radius values. Sometimes by mistake people used to enter the values of dia, that is they know the outer and inner diameter, so they enter the values of that. So don't enter the values of that because the results will not come accurate. So always make sure to enter the values of radius. So let's say, suppose I have the radius as 12.5 and 9.5. That is my this is my assumption. So it may or may not be perfect. My thickness is 3 mm. So my inner and outer radius is 12.5 and 9.5. Okay, so I will rename it as tube section, or say CIR circular section. as you all know, your actual thickness of the pipe is, as this is the tutorial in which I am showing you how to do the process. It is not the actual one. If you have the actual data, that is, if you have the thickness, say somewhere around 2.3, let's suppose 3 mm, if you have any thickness. So if you have the outer and inner data, I'll show you that also. If you have the outer dia as 25 and inner dia is somewhere 22 mm, then radius will be 12.5 mm as outer radius, and the inner radius will be 11 mm inner. So the actual thickness will come as 3, because the thickness calculates from inner dia, the difference between outer dia and inner dia comes as the thickness. Okay, so if you want to input the values of radius, it will come as 12.5 and 11. Don't calculate as per the radius the difference of 3, that is the thickness. Otherwise, actually the thickness will comes as 6 mm, that is the double. Okay, say suppose this, if I multiply it for the dia, multiply by 2, so it is 25 the outer dia, and inner dia will be 19. So my 25 minus 19, that is 6 mm, my thickness has comes like thickness as 6 mm. Okay, so always make sure that you enter the correct values. Again, click on this icon to move to the HyperMesh GUI. So on the model browser, you can see my beam section, first beam section has been created. Now I will create one more beam section for thin walled box and say create. So you have to enter these values as per the actual values, that is, I'm just taking the basic example, that 12, 12, 1.5. Here I will rename it as box section. Again, click on this option to move to the HyperMesh GUI. Now my two cross sections has been defined. Now my next step is to define the property. So to define the property in HyperMesh, click on property icon. Select circular property, name it as circular. Select the create radio button, select property name as circular property. Define a color so that we can easily see these elements by component color, property color, material color. Define the different color. Select the type as 1D because we are going to create 1D elements. Card image as P-beam because we are going to create beam elements. In the theory portion, you can see what is the difference between beam, bar, rod elements. You can go through the theory portion of it. Then click on the material and select the material as steel. Select the tube section as circular section. Once you click on beam section, select circular section. Click on create edit. You can see all the values required to define the physical property has been automatically calculated. That is the area, polar moment of inertia, centroidal axis, everything is calculated automatically. Then create one more property as square section. Define a different color. Type same as 1D, card image same as P-beam, material same as steel, but this time the cross section, that is the beam section, is as box section. Click on create edit it, the values changes. Now on the model browser you can see the properties has been defined. Now my next step is to define the appropriate component for this property, so my element will move toward that particular component. So to create the component, go to component icon, select roll cage circular, define a different color, say create, and no, we have to define the property also. So again, circular, from this no property, select circular prop and say create. So my property has got created, and then create roll cage square property as a square section and say create. Also change, you can change it from here, the color you can change it from here. I will pick this as the different color. Now my material, beam section, property, component, everything is done. Now the next step is to directly do the meshing. So go to 1D to do meshing, 1D beam meshing. For the entire roll cage, do 1D, go to 1D line mesh panel. Once you enter to 1D line mesh panel, from the drop box select lines, click on the lines and say all, just click on all. Again click on the lines and just click on all. Select element size somewhere around 10, so it will be properly densed. If it's very coarse, so that means your model is not in per mm. There is something wrong in your model. Then select the line as a whole segment, so it will not create a break angles and calculation stuff. Select element configuration as bar 2 property. First select the circular property. So in this model I am going to create the beam sections for entire base model. So for the entire base I am going to create the square section. So I will deselect all these base lines. So you can see, you just left click on it. Once you left click, it will get deselected. Right click will select it, and shift plus left click drag, it will deselect. Shift plus right click drag, it will select that particular thing, whether it is line, surface, element, everything it will select. Select the properties as a circular property and click on mesh. Click return, accept the mesh which it has done. Now again you have to just off this. If it's showing something like this, this is the beam element, it is showing element C beam. So you can off it from here and select these lines. So now before selecting it, I will just save as. So as you can see, my roll cage square is the current component. So the circular meshing has moved to the square one. So I will again go to tools, organize, elements, select all the elements and move it to circular. So now you can see it has moved to circular one. Then again go to 1D line mesh, lines retrieve. So the lines which I have saved, I will retrieve those. Change the property to square section and say mesh. So it will do the required meshing for the square section. So I will off these lines. Now you can see this is my mesh model. The upper one are circular cross section, the bottom base is the square cross section. So I can see this cross section. To see the cross section, click on the drop box for this icon, that is the element representation, and represent it into a 3D. Sometimes this type of things happen. So if it shows like this, just click on this, it will show you in the shaded geometry. So in this way you can see it has created a cross section. So there are some errors. Sometimes some softwares doesn't show these types of 3D representation and errors. So but they have those errors, but they don't show them, and they just solve this model. So that is also not correct. As you can see here, the mesh turns up. This happens everywhere. So just the meshing is turned. So that you can also edit it. I will show you how. So I will just show you the one way that I will mask it, mask and reverse. So you can see this is the square cross section and this is the circular cross section. Okay. Now I will edit one by one all. I will again show you first the elements by property color, why we have given the different colors, so that we can easily see whether the elements are assigned with proper property or not. So yes, the circular one is assigned with the circular property and the square one has assigned with the square property. Same for the material, as the material is same for all the elements. So every element is getting green color, that is the color of material. So I will one by one solve the error. So I will off the circular mesh on the line case data. So here you can see the baseline model here. If I go to the line mode, it is showing the meshing, but if I am going to the 3D representation, it is not showing the mesh because the orientation is not proper. So how to update or edit the orientation, I will show you that. So off the geometry first, go to 1D, bars, in 1D select bars, go to update panel, select those elements which you want to update. Like this one, and the other one is this. Shift plus left mouse button, drag the window to select multiple elements. As you can see, the orientation stands for along which axis you want to orient. So as you can see, the cross section is in YZ plane. So I have to orient this, and the length of this particular beam in Z axis. So I have to orient this into Y to define the cross section. So you just define the axis as Y. Always select any axis perpendicular to the length for the orientation. So the cross section will get defined. Select the property as the square section, beam type as C beam. These two are very important. Then click on update and update everything, that is local axis, pink flanks, property, offset values, element type, everything. Then again, if you go to traditional representation, you can see the area where it is not showing the proper orientation, now it is showing. Okay, here you can see. Now I will off this, and on the circular one, again I will go to the circular one and see where exactly the issue is. So you can see these are the areas where the cross section is not properly defined. Same, the axis is Z, I have to orient in Y. So again I will move it to the line mode of the geometry and select these lines. Similarly, the other one is off the geometry, on the geometry. The other one is this one. Select as circular property, orientation as Y, element type C beam, and say update. Update all the axes, everything, and say update. You can see in the traditional mode it has got updated, but we have left with the top one. So again go to line mode, select. These also has got twisted, so I will select the orientation as y-axis because this length is also in x. So if I move it to the 3D mode, you can see there is a twist and say update. So if you update it, so now you can see they are properly updated. So my entire roll cage data is now properly orientated with all the connections, everything. So again I will move it to the traditional element representation of the geometry. Now I will go for the elements connectivity check to check whether all the elements are properly connected or not before going for the run. So in this way my meshing is done, mesh editing is done, everything is done. So go to elements quality check, go to tools, on tools click on check elements, select the radio button as 1D because those are 1D elements and click on free 1Ds. So it will show you those which are free 1D elements. So these are the free 1D elements. There are 6 free 1D elements. So I will show you how to correct these free 1D elements. So click on save field. So it will save all these 6 free 1D elements, or directly go to shift F2. As you can see there in these locations we have the free 1D elements. Or go to mask or go to shift F2 clear all. So these are the locations, or directly go to mask, elements, retrieve. So it will retrieve all these 6 elements which it has saved. Say mask and reverse, so only those 6 elements are displayed. Then press shift F2 and add the nodes, so that if you all on the complete geometry you can see only these elements which are not connected. So press F2 from your keyboard and add some more nodes around these elements, so that we can delete those elements and create new elements same we have done for the line data. So this is not connected, so press F2 and from the drop box select element, say delete. Similarly see as this one is connected, so I will go to, or else I can delete these also. So I will go to 1D bars to create new elements. Go to 1D page, bars. As my roll cage square is the current components, always make sure which is your current component. If you have 2 different components or 2 different cross section, always make sure which is your current component. First create those bar and then make the other component the current one and then do the meshing. So go to bar 2, from node A to node B create one, from this to this create, this end to this end create. Now if you create this end to this end, it will create a square section, so you just right click on it, so these have been created. So I will now make this as the current one, circular, make current, and then go to 1D bars, from element first I will select the circular property. I will make this into 3D representation first to check. Oh, they have I have created the circular property here, so I will again go to delete panel and delete these elements. From this end to this I will make it a 3D representation. That is perfect. Then make the square as the current one, change the property to square, keep all the other parameters as it is, say Y orientation. So this is now properly connected. Shift F2 and remove these nodes. Don't click on clear all, just click on clear. Again delete these elements. We'll follow the same property as a square section. So first create the square sections and then property as the circular. Make the circular component as the current. So the mesh will go to that. The element will go to that. Shift F2, select this and say clear. F2, delete, or we will delete one by one all, because we have the nodes. If we have the nodes, we will delete the elements. That is not the point. So first we have circular one. So select circular cross section, orientation as Y. So from this end to this end, this end to this end, this end to this end, and this end to this. Then make the square as the current, the property as a square section. From this end to this end, from this to this, this to this, this end to this to this. Similarly, from this end to this. From one node to another node, you can create elements. Same as lines. If you convert that into 3D representation, you can see. So Shift F2, now you can click on clear all to clear all the elements, make it into traditional. Again go to tools or press F10 from your keyboard to enter to quality check panel. Again click on free 1Ds. So you can see no free 1D elements. So all the elements are now properly connected, properly oriented. So no free 1D nodes or no free 1D elements. Now we will do a basic free run to check the elements connectivity and quality, so that if the free run passes all the analysis, that is the front impact, side impact, torsional analysis, bump analysis, everything will pass on this meshing. So to check the elements, whether the elements will pass for the analysis or not, we can go for the free run. If it's not passing, we can edit it at the same time also. So to go for the free run, we need to define a load collector with a frequency range of 1 to 1000. That is the just assumption. That is not any frequency range. We need to see whether all the beams are properly connected or whether this model is solving or not. So click on load collector, enter the load collector name as EIGRL, card image as EIGRL, click on create edit, select the values of V1, V2 and ND. V1 stands for initial frequency, V2 stands for maximum frequency. So I will excite this model for maximum frequency of 1000 and ND is number of modes. So I'll select the number of modes as 10. So in the model browser you can see my load collector has been defined. Now the next step is to define the load step, that is the type of analysis I'm going to perform. So go to define the load step, go to analysis, in analysis select load step. Enter the name as free run. Select the type as normal modes. Check the box in front of method structure and select EIGRL and click on create. So in this way my complete model is ready to run. My solver deck is complete. Now go to file, save as, create a folder as free run, save the file, that is HM file there, and then you can go to analysis, radios, select the export. To solve this model, go to analysis, radios, export option to all, run option to analysis, memory option to default, and click on radios. Once you click on radios, it will start the solver window. Once this message appears that analysis completed, click on results. If it shows some error, so whether either you have not done the orientation properly, so you have to check the orientation, that is 6 to 8 rigid elements, or there is a duplicate elements, you have to check that also. So there are 2-3 generalized error which can come, or else you can contact us at, I will share you the email ID on which you can contact us. That if you have any query, you can contact us at edu support at india.altair.com. So you can contact us in this mail ID if you have any query related to this. So in this way you can see my HyperView window is open. So this is my HyperMesh, HyperView GUI. So I'm not, so as this model is running, that means it is passing all the elements quality criteria, that is my elements are perfectly fine. So I can now perform any run on this. And now I will check the elements connectivity. So I will see the animation mode as set to modal animation mode because I have performed modal analysis. As the deformation value is just 13, so I will increase somewhat deformation somewhere as 20. So now you can see here, this portion is not connected properly. You can see here, this has to be connected. It is not connected. It is coming out or in. So the rear end or in this portion, these two are coming. So that is the main aim to perform the free run. So you can see here, this one is also the front, the middle, or the back. These all are coming. So first we will solve these. So I will pause this to the extension. Again go to HyperMesh. So these are not properly connected. So press Shift F2, add these nodes. So I will show you now the other way. First way is to create, to join the lines, and the other way is you can directly join the meshing. So these are the areas where the meshing is not properly connected. So similarly, add the nodes, delete those elements, and create new elements, same as the free 1D which we have done for free 1Ds. So from this end, I will start doing it. So go to 1D, bars. First I will select, okay, square section because my current component is square. So I will select square section. Orientation as Y, from this to this, this to this end to this end. Similarly, first I will create all the square section elements. Then I will create circular section elements. So and every time I don't have to move from one to another. So this is done. Now I will change the property to circular. Make the circular as the current. Keep all the other parameters as it is. So here the length is in Y, so I cannot orient in Y, so I will orient this in Z axis for this. Similarly for this one. And for this I will select Y because this is somewhere in Z, or it's an angular, so it hardly matters. Similarly this one also is Y, and for this always try to make the perpendicular one. So this and this. So now I've created all. So Shift F2, clear all. So I've connected these, the bottom ones. Now again go to Hyperview. We will check for second mode, that whether which one is not connected now. So apart from the front one, there is no one. Yeah, this one is, we have done with this. So in this way, from the free run, you can easily check where your beam, whether all your beam sections are properly connected or not. So you can see only that one is missing, otherwise all the beam sections are properly connected. So I will say new, click return, again return, save the file again, free run second, save this file, analysis, radius, and again radius, again click on run. So this file is has run properly. Analysis completed. Now I'll close it. Now again I will go to modal analysis, go to contour, sorry, deform, increase the value as 13 somewhere, select from the drop box animation, or I can put here 50. Go to deform. So now you can see they are properly connected. If I lower down the speed, you can see here, that is the second one. So it is now properly connected. No, none of my beam is coming out of this geometry. Everyone is moving with each other. So now you can see here, all are properly connected. So these are the different modes to check whether my geometry is properly connected or not. All the beams has to be properly connected. So in this way, we have done with the geometry editing. So this is my final file of the geometry editing, that is the roll cage 1D. And now I will perform all the analysis, all the required analysis on this file, that is the front impact, side impact, torsional, bump, modal analysis, all the different analysis in this particular file. So that I'll discuss in the next video. Thank you very much. If you have any queries, any issues related to the support and technical queries, you can feel free to contact us at EDU support. Thank you very much.